Hello, Michael here. Welcome back to the Joy of Code episode 6. Today we will look at making our turtle behave in a slightly more natural or interesting way. We're continuing from the scenario from last episode. So we have our turtle here running around on the screen, and it runs straight and turns at the edges. At the moment this is okay for a start, but the movement of the turtle is very regular. We want to turn this scenario eventually into a little computer game, and for that computer game, for the game characters to run in such a predictable way makes it a bit boring. That is especially true if I have multiple turtles here. So if I shift click to put multiples in here, they all essentially move in sync. It's like a synchronized swimming team. So what we want to achieve today is to give the turtles a little bit more random behavior, where they walk straight ahead most of the time, but every now and then they just turn off course, because naturally turtles would not go in an exactly straight line. They would sort of swerve left or right every now and then, and so we want to introduce this for our turtles, that they can go in some unpredictable random way, a little bit of course. Let's have a look at the source code. Double click on the class here, opens the editor. Here's the source code so far. So our turtle moves forward at every step, and then if it reaches the edge of the world, it turns. What I now want to say is that every so often when it moves forward, it should just turn anyway. Even if we're not at the edge of the world, it should just turn a little bit left or right. The way I can do that is to just give it a probability and a random chance at every step that it turns. I can say, for example, at every step we want to move forward, and then with a chance of, say, 10%, a 10% chance, it should also turn a little bit. And then at the edge of the world it should always turn. But I want to insert here a statement that said with a 10% chance, turn a bit to the side. How can I do this? Well, one thing I can do is to use an if statement. I can say if, and then I need some kind of condition here, and note that the 3 dots is not Java code. This is something that I have to fill in a moment. And then I put a turn statement here, and this also is incomplete at the moment. So I want to say something here where I want to say if something something, then turn. And let's say I just turn 15 degrees for a start. So now this condition here, which I haven't written yet, I need an expression here that returns true in 10% of the time. So if I say if this expression is true, then turn, and that expression should be true with a chance of about 10%. How can I achieve this? Well, in almost all programming languages you have one facility available, that is random numbers. You can get random numbers from the system. Technically, strictly speaking, they're called pseudo-random numbers because they're not actually, mathematically speaking, entirely random. But they are mathematically generated to be a very random distribution. The details of that aren't very important for us. If you're interested, there's a lot of material online. If you Google for pseudo-random numbers, there's a lot of theory behind it. If you're mathematically interested, look it up. So we want to get a random number here. Getting a random number is reasonably easy. In Greenfoot there is a class called Greenfoot available, which gives us some system-wide functionality, and there is a method called getRandomNumber, and this here is the header of the method. It's also called the signature of the method. The signature of the method, we have seen that last time when we used the move and turn methods. The signature of the method, we just repeat quickly how we read this. The thing here in the middle is the name, getRandomNumber, and at the front is the return type, and in the parentheses at the end is a parameter. So we can see here that the getRandomNumber method expects one parameter of type int, which is called limit, and it will return to us an int. And what it actually does is it gives us a random number. So this number that it returns is a random number, and the range of the number is defined with a limit. So the number we're getting out is always between 0 and the limit. There's one little detail to remember, and that is that 0 is included and the limit is not. So if I choose, for example, 20 as the limit, the resulting number that I get back will be between 0 and 19. So the limit itself is excluded, which means if I put in 20, I get 20 possible numbers, and they are 0 to 19. 0 to 19 is 20 different possible numbers that I will get out. Because this method is in the class Greenfoot, not in the actor class, not in my turtle class, when I call it, I have to write the class name in front of it and a dot and get random number. For those who know already a little bit about Java, just quickly jumping ahead a bit, this is a static method. That is why there's a class name here. If you don't know what that means, don't worry. I will talk about that in one of the next episodes. For now, just know that because this method is defined in the Greenfoot class, you have to say which class it comes from when you call it. So you have to say Greenfoot dot get random number. This dot in between, it's called dot notation. We will always use that when we invoke a method that comes from somewhere else, from another object or another class. Now, if I would not show you on my screen here what the method is called and what the signature is, how could you find out yourself? Well, you would, if you work on your own, what you typically do is you go to the main window of Greenfoot, and in the help menu here is an entry called Greenfoot class documentation, and there you can see all the methods that are made available by the Greenfoot framework to you to provide useful functionality. If you choose this, a web browser will open that shows you the documentation for all the Greenfoot classes. And you see here there are 6 classes. So the whole Greenfoot framework is made up out of these 6 classes. There's the actor class, which we have seen already. That is the super class for all our actors in the world, for example, for our turtle. There is the world class here. There's the super class for our world object. We also have seen that in Greenfoot, that is represented here. There's the actor class and the world classes. Those 2 classes actually appear in the interface of Greenfoot here, so we have seen them before already. Then there is a class called Greenfoot, which is the Greenfoot system itself. So we can communicate with the whole system itself, and that is where we get the random number from. We also can get keyboard and mouse input from there, and so on. Then there are 3 helper classes to do image manipulation, to deal with sound, and to deal with mouse input. We will look at those in more detail in later episodes. And that is the whole Greenfoot framework. And now if we want to look in detail into a class, I can click on, say, the Greenfoot class, and I get here the documentation, and there I can get the list of all the methods in this class. And you see there's about a page worth of methods, and later on we will investigate just about all of them. For now we just concentrate on the one that we need at the moment, and here is the get random number method that has the limit as a parameter and returns an int as a result. In the documentation you also actually get some commentary. So this tells you here, return a random number between 0 inclusive and the limit exclusive. If you click on it, you get a little more detailed information. For the get random number method, this is actually all the comment we're getting. That is all we need to know. So back to our code. How do we use this now? So here the question is, if we can get a random number, how can we turn that into an expression that results in a probability? So I can, by writing here greenfoot.getRandom number, and then here I have to fill in some kind of value for the limit. I can get a random number, but a random number is not good in an if statement. We know that in an if statement we need an expression here that gives us a boolean, that gives us either true or false. Greenfoot get random number gives us a number, an integer, so that will not work. So if I get a number, say out of 100, here I'm getting now a random number between 0 and 99. But that is a number. That doesn't work as a condition in an if statement. In fact, if I try to compile this now, you would see that you get an error message. Here, this is what it looks like when you make a mistake in your code and you try to compile. The compiler will tell you that there is a problem somewhere. And down here, at the bottom area of the editor window, you get an error message there. It says incompatible types, found int but expected boolean. And that is because the if statement here as expression wanted something that is a boolean type, that is either true or false, but you have given it a number because this random number is a number. So how can we express something here that is true with a probability of 10%? Well, if I have a random number out of 100, I can just say if this random number is less than 10, and this expression will be true with exactly 10% probability, because this random number here will be between 0 and 99, so 100 possible values, and exactly 10 of those 100 values, that is 0 to 9, are less than 10. So there is, if this is really randomly evenly distributed, there's an exact 10% probability that it is greater than 10. And so when the turtle acts now, at every step the turtle will move, and then at every step again it will get a random number. That is essentially, it's like rolling dice. You know, it will roll some dice, and if the result is less than 10, which has a 10% chance, then it will turn a bit to the side. And if we're at the edge of the world, then it will turn also. Let's try that out. I compile this, select this, shift-click to place the turtle into the world, and we see it seems to be working. So the turtle moves straight for a while, and every now and then it turns a little bit while it's moving. So there are still a couple of things that I want to improve here. First of all, it always turns the same amount. Every time it turns 15 degrees. And I want to make this random as well. And secondly, what we observe, every time it always turns right. It never turns left. Let's fix those two things. First of all, what if I don't want to turn 15 degrees? Let's say I want to turn a random angle up to 20 degrees. Well, this is pretty easy now, because here the parameter to the turn method, there needs to be an integer. And the getRandomNumber method gives us an integer, a random integer, between 0 and a limit. So if I copy this, and then here, I paste it here. So as the parameter for my turn instruction, my turn method, I now use a random number as well, but not up to 100, but out of 20. So here I now have a random number between 0 and 19. And when I turn, I don't turn always 15 degrees, I turn a random degree between 0 and 20 degrees. In fact, strictly speaking, excluding 20, so it's actually between 0 and 19 degrees. The turning 0, which can happen, will actually have no effect, but that's good enough for me because I don't care about that. So if we look at this now when the turtle turns, we can see that it actually turns a little bit more irregularly. That is good because I wanted irregularity in the behavior. The next thing that I want to fix is that the turtle always turns only right and never left. So how can you turn left? Well, one theory is to turn a negative amount. We have turned 15, we have given a positive 15, and we have seen that that turned 15 degrees right. It's a fairly reasonable guess that if I say turn minus 15, that it turns 15 degrees left. But so far it's a guess, right? We haven't seen that working. How can you find out? Well, there are two ways. First, you can read the documentation. You can go to the Greenwood class documentation, look up the actor class, look up the turn method, and read the description. Or you could just try it out. Let's see, our turtle is facing the upright, and I can just say here, right-click on the turtle and go to the turn method, which is inherited from the actor class, so it's in the actor submenu here, and there's my turn method. And then I just try putting in minus 45 degrees, and I would expect it, if I'm right with my guess, to turn 45 degrees left. Let's keep an eye on the turtle, click OK here, and yes, it has turned left. So turning a negative amount turns left. So here, essentially now, I want to turn, where I'm turning, I want a random number between -20 and +20, so that I get turns up to 20 degrees either right or left. Now that is a little bit tricky, because the random number method will give us always positive numbers. It will never give us a negative number. We cannot specify the lower limit. We cannot say that the lower limit should be -20. The random number method is just written in a way that the lower limit is always 0. But one thing we can do, because -20 to +20, that is 40 different possible numbers. Actually, strictly speaking, it's 41 different numbers because the 0 is included as well. But since this is not necessary to be very precise, let's say it's 40 different numbers, I can get here a random number out of 40. So this expression, greenfoot get random number 40, gives me a number between 0 and 40, and then I subtract 20 of it. And that, if we think about it, will result in a number between -20 and 20. Because here, if the random number is 0, and I subtract 20, I end up with -20. If the random number is 40, and I subtract 20, I end up with 20. So anything in between will be between -20 and 20. Let's try that out. I compile, place a turtle into the world, and run this. And there my turtle goes, and it doesn't go exactly straight. And now, especially if I have multiple turtles in my world, it looks much better because they don't all go completely in sync. They actually individually have individual random behavior, so they don't all turn at the same time. They turn at individual random moments, and they walk across the screen. If you think they should turn a bit more, you can play with the parameters. You can turn them, either make them turn more often or make them turn larger angles, and they will then change sort of the pattern in which they walk. This is getting a bit better. We will, over the next 3 or 4 episodes, turn this into a real little computer game where we have our turtle called Trick, which will try to evade some predators and do a few things. This is enough for today. Play around with your random numbers, try them out, play with Greenfoot, and come back for the next episode. See you then. Bye bye.